Hello, you are welcome to this teaching. Now today we want to look at how do we solve when we have equation of circle and a tangent that pass through that circle. And when we take a tangent, that means we have a line. You see this line PR is a tangent to this circle because it touched that circle at a point. It touched the circle at a point. So in a situation whereby we have an equation of circle and we have an equation of the line of tangent, how do we go about the solving? Now, don't forget that from our equation of circle, our equation of circle, we have it as x minus a all square plus y minus b all square equals to r square. Where our a comma b is the center of the circle. We should not forget this. And r is the radius of that circle. So a and b is the center of circle and r is the radius of that circle. So that means we are given a center AB and we know the radius. We can form the equation of circle of this form. And now what we are trying to say is now when we have that equation of circle, we have a circle here. You see this is the center. So that's what we are saying. Maybe the center is A comma B. And the line from the center to this circumference is called the radius. So the distance from the center and a point on the circumference is called the radius. And also we can call this also the radius. So two radius we say is diameter. So the length from one circumference of this to the other circumference, we say is the what? The diameter of that circle. So once we know the radius, we know the center of our circle, we can form the equation of the circle. But what we are going to look today is how do we relate when we have a line of tangent passing through our circle at a point. Passing through our circle at a point. You see here, PR here is a tangent. PR is a tangent. And don't forget, we need to go back to our quadratic when we have a quadratic curve intersecting by a line at a point. You know what our discriminant says there. That means when we have it, our discriminant there is b squared minus 4ac will be equals to 0. So that's what we are going to use. That means that when we have a circle intersecting by a tangent, you should not forget this discriminant by a tangent, b squared minus 4ac equals 0. You know, these are our discriminants. These are our discriminants. So let's move to a question that looks. Now we are having the equation of circle as x minus 6 all squared plus y into bracket y plus a all squared equals 18. That's the equation of circle. And we are given that the line with equation y equals to 2a minus x is a tangent to that circle. Now we have a circle now and we have a tangent to it. Don't forget, a tangent passes through a circle at a point. At a point. The question now says find the two possible values of the constant a. Find the two possible values of the constant a. Don't let us forget that when a tangent passes through that circle, at that point, the value for y is the same. At that point of intersection, at that point, the value for our y is the same. So what we are just going to do here, since we have our equation of line as this, y equals to this, 2a minus x, we can substitute this value of y into this equation of circle. And our equation of circle now becomes in terms of x and a. So we can now use our discriminants to solve for the value of a. What are we saying? We are saying that x minus 6 all squared plus y into y plus a all squared equals 18. Now we want to substitute the y for the tangent into the circle. So we are saying x minus 6 all squared plus, if we substitute that into the circle, that means we have 2a minus x plus a all squared equals 18. So if we simplify further, we have x minus 6 all squared plus bracket, this one will be 3a minus x all square equals 18. So that means we need to expand now. We need to expand. So if we expand x minus 6 all square to give us x squared minus 12x plus 36. Plus, if we expand 3a, we have 9a squared minus 6ax plus x squared equals 18. Now let's make it look like a quadratic equation. We have x squared here, we have x squared here. We can collect like terms, and that would be 2x squared. This is in terms of x. This is also in terms of x. We can bring it together, minus 12x minus 6ax. And we can take the constant, that we have plus 36. If I bring this 18 inside, that becomes minus 18 plus 9a squared equals to 0. We want to make it look like a quadratic equation. So let's simplify further. We have 2x squared. Now I want to factor out x here so that I can know the coefficient of my x into bracket minus 12 minus 6a. This one 36 minus 18, that will be 18 plus 9a squared equals to 0. If you look at this, this has given us a kind of quadratic equation. The coefficient of our x squared here is 2. The coefficient of x is 12 minus 6a. And the constant term is 18 plus. So that means if we are importing using our discriminant, don't forget, I say our discriminant is b squared minus 4ac equals to 0. So we need to identify our a, b, and c. And don't forget from our quadratic equation, our a is the coefficient of x squared. That means we have a equals to 2. Our b is the coefficient of x, that's minus 12 minus 6a. And our c is the constant term, which is 18 plus 9a squared. So in simplify our discriminant, which is b squared minus 4ac, that means we are saying that b squared, that means minus 12 minus 6a all square minus 4 into bracket. My a is 2 and my c is 18 plus 9a squared will be equals to 0. So if I expand it, this will give me 144 plus 144a plus 36a squared. This will give me minus 8 into bracket 18 plus 9a squared equals 0. So that means that we have 144 plus 144a plus 36a squared. If I expand this, will give me minus 144 minus 72a squared equals to 0. So minus 144 plus 144 cancel. That means plus 36a minus 72a. That means that one we give, where we have 144a minus 36a squared equals to 0. Equals to 0, equals to 0, equals to 0. Now, let's go. We have 144a minus 36a squared equals to 0. Don't forget, we are looking for the true values of a. What's common here is 36a into bracket. This will be 4 minus a equals 0. From this first one, we can see that our a equals to 0 or 4 minus a equals to 0. So a equals to 0 or 4. Those are the two possible values for our a. A equals to 0 or 4. If you go back to the question, that's what it says. Say find the two possible values of the constant a. That means our a equals to 0 or 4. Now, the second aspect of the question is saying for the greater value of a, the greater value of a here is meaning that a equals to 4. Find the equation of the diameter, which is perpendicular to the given tangent. Now, equation of the diameter perpendicular, if you look at this, that means from this circle, this line, which is diameter, is perpendicular to this tangent here. And don't forget our law, when we have a perpendicular when lines are perpendicular, how to get the gradients? We say the gradient of the first line, the second line multiplies together to give us -1. But to go about this question, we first need to get the equation of our tangent. Don't forget, we say y equals to, from the question, 2a minus x. 2a minus x. And don't forget, our a is 4. So that means my y will be equals to 8 minus x. So the gradient of this tangent is, if you compare it to our equation of a line, like y equals to mx plus c, we find out that the coefficient of our x here is the gradient for this tangent. So the coefficient of x here is 1, is -1 rather, sorry. That means our gradient for that tangent, I call it m1, equals to -1. Since our diameter is perpendicular to that tangent, I can get the equation of my diameter, say it is m2, as -1 over m1. And that will give me -1 over -1, and that will be 1. So the equation of the gradient of my diameter, which is m2, is 1. So I can write it as y for the equation of the diameter now equals to mx plus c. For the gradient for this one now is 1. It will be y equals to x plus c. But we don't know the c, the y coordinate, the c there. And before we can get an equation of a line, that means we need to know the gradient and a point on that line. And don't forget, since it's a circle, a point on that line of the diameter is also the center of our circle. A point on that line of the diameter is also the center of our circle. And if you go back to the equation of the circle, we are given that x minus 6 all squared. If you substitute the value for a, that will be y plus 4. We are given that x minus 6 all squared plus y plus 4 all squared equals 18. If you check this minus 6, this here is our center. So our center, which is a comma b, will be equals to, if you compare it, that means we have 6 comma minus 4 as the center. And this center of the circle is a point on that diameter, is a point on that diameter. So by this as x and this as y, I can substitute it into this equation and I will get the value for c. And if I get the value for c, that will make the equation to be complete as the equation of the diameter. Now, if my y is now 6, I will say that 6 is equals to x is -4 plus, sorry, our y there is -4. Our y there is -4. Our y there is -4. That means -4 because our x is 6 plus c. So -4 minus 6 equals to c. My c equals to -10. So the equation of the diameter can be y equals to x minus 10. So this is the equation of the diameter that is perpendicular to the tangent. That is perpendicular to the tangent. Thank you.